Now we are going to discuss about diffusion and drift currents. So here, diffusion current is the current which is due to the transport of charges occurring because of the non-uniform concentration of charged particles in a semiconductor. Now in this diagram we can see there is a larger concentration of electrons on this side and there is a less concentration of electrons on this side. So because of that concentration difference between these two sides, there is a flow of electrons from the higher concentration region to the low concentration region. So this process of movement of these electrons will be called as the diffusion of electrons. And since the flow of electrons, we call it as a current, this flow of electrons moving from high concentration to low concentration region will be giving rise to what is called as the diffusion current. Now this diffusion will be continuing until an even distribution of charges will be taking place. So in this case we can see the net diffusion current is zero diffusion current, which is because of the carrier concentration gradient. Next, drift current. Drift current is due to the motion of charged carriers due to the force exerted on them by an electric field. Now we can see we have connected this semiconductor material to a battery here. So when we are connecting this semiconductor material like this, the electrons and holes will be moving in the opposite directions. So there is a flow of electrons towards the positive terminal, that is, you can see this arrow indicating the direction of flow of electrons. This is the direction of flow of electrons. These are the electrons moving towards the positive terminal, and the holes will be moving in the opposite direction to that of the electrons. So there is a flow of electrons and holes because of the applied voltage here. So because of this external field, a force is exerted on these charged particles and they will be moving in the opposite directions, constituting the hole current and the electron current. So these currents are called as the drift currents. Now we'll see the diffusion current density. So diffusion current density is given by Jn, and that is proportional to the gradient of carrier concentration. So here dN by dx is giving us the gradient of carrier concentration with respect to the x-axis. So Jn is equal to Q into dN, where capital Dn is giving us the diffusion constant of electrons. So Jn equal to Q into dN into dN by dx. Similarly, the current density due to holes is given by Q minus Q into dP by dx, where this dP is called as a diffusion constant for holes, and this is the carrier concentration gradient. Next, drift current density. Drift current density due to the electrons, we know this drift current density is proportional to the applied electric field. Jn equal to E into N into mu E, which is the mobility of electrons into the electric field. Similarly, the drift current density due to holes is given by Jp equal to E into P into mu P into E, where mu P is the mobility of the holes and E is the electric field, where small e is the charge of the electron and P is the hole concentration here. So the overall current density with respect to electrons can be given as Jn equal to drift current plus diffusion current. So the drift current because of electrons and diffusion current because of the electrons. So Jn is given by En into mu n into E plus E into dN into dN by dx. Similarly, the overall current density with respect to holes can be given by Jp equal to drift current due to holes plus diffusion current due to holes. So Jp equal to Ep into mu P into E minus E dP into dP by dx. And the overall current density is given by Jn plus Jp.